In this video, I am going to explain detectors used in gas chromatography, advantages, disadvantages and applications of gas chromatography. In previous video, I have explained introduction, theory, sample preparation, sample derivatization, sample injectors, columns used and temperature programming in gas chromatography. Links of those videos are given in description box. If you are new on my channel, please subscribe. Now let's start today's video. First we'll see ideal characteristic of ideal detector. First characteristic is detector should have good sensitivity. Now good sensitivity means it should detect trace amount of solute in sample. Flame ionization detector can detect up to picogram or femtogram level of sample, while thermal conductivity detector detects up to nanogram sample. So, flame ionization detector has good sensitivity than TCD detector. Next is it should have good stability and reproducibility. Now, what is reproducibility? If we inject same sample 10 times in the GC, we should get almost same result for all those 10. Reproducibility. It should have short response time. Detector should detect the sample quickly. Flame ionization detector, electron capture detector have very short response time. Detector should be non-destructive in nature. That means while detecting, detector should not destroy the sample structure. If we want to collect our sample back or our solute back for further analysis, destructive detectors are not useful. In that case, we have to select some non-destructive detector. Thermal conductivity detector is non-destructive detector. Detector should work at high temperature. As we are talking about GC detectors, it should work at higher temperature. Now we'll see different detectors used in gas chromatography. There are number of detectors used in gas chromatography. Few detectors I am going to cover here. First detector is thermal conductivity detector, which is also known as TCD or Katharometer. Second is flame ionization detector, which is known as FID. Third detector is electron capture detector, ECD. These are most commonly used detector in gas chromatography. Fourth one is nitrogen phosphorus detector, NPD, and fifth one is mass spectrometer detector, that is MS. Now, thermal conductivity detector and electron capture detector are non-destructive detectors. They do not destroy the structure of sample, while flame ionization, nitrogen phosphorus detector and mass spectrometer detector, these are destructive detectors. They destroy the the structure of sample. Now we'll see each detector in detail. First detector is thermal conductivity detector, also known as Katharometer. First we'll see construction and working. This detector has a metal block with two cavities. Four tightly coiled tungsten filaments are mounted in these cavities. Two filaments in each cavity. So four filaments are mounted in these cavities. Two filaments in each cavity. These filaments are connected to an electrical circuit which will form four arms of Wheatstone's bridge. These filaments are heated electrically. When through both these cavities pure carrier gas is flowing, these filaments will get cooled, because when only pure carrier gas is flowing through these cavities, these filaments will get cooled, because the thermal conductivity of carrier gas, pure carrier gas, is excellent. For example, if the carrier gas is hydrogen or helium, their thermal conductivity is excellent. They will carry heat from the filament to the metal block and the filaments will get cooled. As these filaments are cooled, the current flowing through them is constant. But when through one cavity pure carrier gas is flowing and through the second cavity the column effluent is flowing, that is vaporized solute molecules plus carrier gas if it is flowing, the filaments in second cavity remains heated because the thermal conductivity of carrier gas is reduced due to presence of vaporized solute molecules. Now as the filaments are heated, the current flowing through them is reduced because the relation between temperature of wire and current flowing through it is inverse. If the wire is heated, its resistance is increased and current flowing through it is reduced. So here in the second cavity, the current flowing through the filament is reduced. The difference between current flowing through these filaments is sensed by a sensor and we will get chromatographic peak. Principle of this detector: it works on the difference in thermal conductivity of pure carrier gas and gaseous solute molecules. The thermal conductivity of hydrogen or helium is generally 6 to 10 times greater than most of the organic compounds in gaseous form. Now we'll see advantages and disadvantages of TCD. Advantages: it is most simple detector of GC. It gives linear response, that means as the concentration of solute increases, the response given by the detector is also increasing. It can detect both organic and inorganic solutes. It is non-destructive in nature. The solute structure is not destroyed by this detector. Now next we'll see disadvantages. First is it has low sensitivity. It can detect up to nanogram solute. Its sensitivity is less. Now we'll see applications of TCD. It is a universal detector and it can detect both organic and inorganic compounds. Even though its sensitivity is less, it is used widely. Second is flame ionization detector, its construction and working. At the end of GC column, platinum jet is placed which will carry column effluent. This column effluent is mixed with hydrogen gas and air because flame is going to burn, and for burning of that flame air and hydrogen is required. Hydrogen is provided separately if it is not used as carrier gas. The platinum jet will act as polarizing electrode and another electrode which is known as collector electrode is placed at the top of flame, and this whole thing is present in a chamber. The potential difference is applied across these electrode. It is about 400 volts. The flame of column effluent, hydrogen and air is burnt at the tip of jet. When only pure carrier gas is burning in the flame, some ions are generated in the flame and they will get attracted towards the collector electrode. It will cause a constant current to flow between these two electrodes. But when, along with carrier gas, some solute molecules are burning in the flame, it will create large number of carbon ions in the flame, and these carbon ions will get attracted towards the collector electrode, and it will increase the amount of current flowing through these two electrodes. As the amount of solute is more number of carbon ions are generated and there will be increase in the current. When only pure carrier gas is flowing, a constant current is generated. When solute molecules are burning in the flame, the current will increase and we will get peak for our solute molecule. Flame ionization detector is based on difference in electrical conductivity of gases. At normal temperature and pressure, gases will act as insulator, but they will become conductive in the presence of electrons. So this is the principle of flame ionization detector. Now we'll see advantages and disadvantages. Advantages: it is a highly sensitive detector. It can detect the solute up to picogram or femtogram level. It gives linear response. It is insensitive to presence of moisture, presence of water or presence of air in carrier gas. It cannot detect hydrogen, oxygen, carbon dioxide, carbon monoxide, nitrogen dioxide, water, etc. It is beneficial in analysis of many organic samples and air pollution studies. Disadvantages of FID: it destroys the sample. Now applications of FID. Flame ionization detector or FID is widely used because it sends carbon ions, allowing it to detect virtually all organic compounds. Next is Electron Capture Detector ECD, construction and working. This detector has two electrodes. One electrode is coated with radioactive isotope nickel 63. Here in this case the cathode surface is coated with radioactive isotope. Other electrode is collector electrode. It is anode in this case. Voltage difference is applied across these two electrodes. There is an inlet for column effluent and there is an outlet. The radioisotope emits electrons. Gas eluted from column is passed over the surface of radioisotope. The electrons react with the carrier gas molecule, and these electrons will ionize the carrier gas molecule and produce large number of secondary electrons. Due to the voltage difference, these secondary electrons get attracted towards anode and current will be flowing through these two electrodes. If only carrier gas is flowing, then steady current will be produced. But if some solute molecules which has tendency to capture electrons, the amount of current will be reduced. This reduction of current is proportional to the amount of solute present in sample. If the solute molecule has halogen, sulfur, phosphorus or nitrogen or any electronegative group in its structure, then these solutes will capture the electron, and as the number of electrons is reduced, the amount of current is also reduced. Now here in this detector, a steady current is flowing if only carrier gas is there flowing through the detector, but if the solute molecules which has tendency to capture electron, the amount of current will reduce, and as the solute molecules goes out of the detector, they go to the exhaust, the current will come back to its normal constant state. Now here in this case a invert peak is obtained in electron capture detector. The software will convert into a regular peak and will get chromatographic peak by this ECD detector. Now we will see advantages and disadvantages of ECD. Electron capture detector is 1000 times more sensitive than flame ionization detector for the molecules which has electronegative functional group. It can measure solute components in parts per billion or parts per trillion level. It is much sensitive detector. It is a non-destructive detector. Now disadvantages. It is insensitive to functional groups such as amines, alcohols, hydrocarbons, etc. Applications of electron capture detector. It is used in environmental testing for detecting PCBs, polychlorinated biphenyls. Polychlorinated biphenyls are man-made chemicals which are contaminating food, air, water, soil, and large amount of PCBs are harmful to human health. So electron capture detector is used in environmental testing. It is used in environmental testing for organochlorine, pesticides, herbicides and various halogenated hydrocarbons. So electron capture detector is a very important detector in case of environmental sample. Next is nitrogen phosphorus detector. It has many names. It is also known as Thermionic Specific Detector or Alkali Flame Ionization Detector or Thermionic Emission Detector. This detector is very sensitive to nitrogen and phosphorus containing compounds. Construction of this detector is almost same to the flame ionization detector. It has a flame burning at the end of column which is supplied with hydrogen and air. The difference between flame ionization detector and nitrogen phosphorus detector is that a rubidium silicate bead is placed 1.25 cm above the flame tip. This is the rubidium silicate bead which is present above the flame tip. This bead is electrically heated. Now this rubidium silicate bead is present in a heating coil and it is heated electrically. Two electrodes are present. One is a collector electrode. A fuel poor hydrogen plasma or low temperature flame is used in this detector which will suppress the normal flame ionization response and enhance the response to the nitrogen and phosphorus containing compounds. Here hydrogen plasma is generated due to use of low temperature flame, and when nitrogen and phosphorus containing compounds burn in this hydrogen plasma, they will increase the amount of current flowing through the electrodes. Exact working of this detector is not known, but this detector is most sensitive detector for nitrogen and phosphorus containing. Now we will go for advantages and disadvantages of nitrogen phosphorus detector. First advantage is it gives 104 to 106 times more response to nitrogen and phosphorus atoms than carbon atom. The response to phosphorus atom is 10 times greater than the nitrogen atom. It is more sensitive than flame ionization detector. Disadvantage: it is not a universal detector. It destroys the sample. Now we'll see applications of nitrogen phosphorus detector. It is used in analysis of food. It is used in forensic analysis. It is used for analysis of environmental samples. Now next is mass spectrometer detector. When GC uses mass as detector, the technique is known as GCMS and it is a hyphenated technique. The separation capabilities of chromatography are combined with qualitative and quantitative detection capabilities of spectroscopy. Mass spectrometer is a powerful detector of GC. It measures mass to charge ratio of ions produced from sample. Here the sample injection system and carrier gas connected to it, they are present in the oven, and in the oven separation column of GC is placed. This separation column is then connected to the mass spectrometer. Now in GC the sample is under atmospheric pressure, while in mass spectrometer the sample is under vacuum. So to interface these two systems, a proper transfer line or a proper inlet system is required. When the column effluent enters mass spectrometer, it enters at the ionization source or ionization chamber. The solute molecules will get ionized in this chamber and they will convert into positively charged ions. Now these are the focusing lenses which will focus these positively charged ions. These positively charged ions will then enter into the mass analyzer. In the mass analyzer, these ions will get separated or sorted according to their mass to charge ratio, and these sorted ions will then enter in the electron multiplier tube, which is the detector here. This electron multiplier tube will give response to each of these separated, positively charged separated ion, and we will get chromatogram in the recorder. So this is about GCMS. Now next we'll see advantages of GCMS. The speed of analysis is very fast in GCMS. It gives total ion chromatogram. One can select a single mass to charge value and monitor it throughout the chromatographic experiment, and this is known as selected ion monitoring. Now disadvantages of mass spectrometer as detector. The disadvantage is only that it is an expensive technique. Now we'll see overall advantages and disadvantages of gas chromatography. Advantages: gas chromatography is a highly efficient technique which can separate complex mixtures. It gives sharp reproducible peaks. Highly sensitive detectors are available in gas chromatography. Disadvantages: gas chromatography can be used for analysis of thermally stable and volatile compounds. Most of the detectors used in gas chromatography are destructive in nature. Applications of gas chromatography. First application is qualitative analysis. Gas chromatography is widely used to establish purity of organic compound. In qualitative analysis, first one is identification of unknown compound. For identification of unknown compound, we require a standard peak. On x-axis there is retention time, and on y-axis there is detector response in chromatogram. Now suppose this is the chromatogram of standard substance and this is the chromatogram of sample substance. In identification we have to compare retention time of both. Now these standard and sample peak are taken in identical and instrumental conditions like flow rate of mobile phase, temperature of column, detection system. These identical conditions are followed for both standard and sample peak for their run. Now under these identical conditions, the retention time of standard is 1.55 minute, that is 1 minute 55 second, and for sample we get the retention time, same retention time, that is 1 minute 55 second. Now the retention time of sample and standard is same, so we can say that these are same substance. So in this way we can identify the sample. Now suppose there is another substance whose run we have taken under the identical conditions of mobile flow rate, mobile phase flow rate and detection system. Under these identical conditions, if this peak is obtained for second sample whose retention time we got, it is 3 minute 5 second. Now the retention time of sample and standard is not matching, so we can say that these two are not same substance. So in this way identification of unknown substance can be done by using gas chromatography. Next is to check purity of organic compound and to detect presence of impurities. Now suppose this is the peak of next sample. In this chromatogram we obtain the retention time. Retention time is 1.55 minute. The retention time of sample and standard, it is matching, so under the identical chromatographic conditions. But in sample chromatogram some additional peaks are present which are not there in the standard chromatogram. So we can say that some other substance, some impurities are present in our sample. So in this way we can identify the presence of impurities. Now next is Quantitative analysis. In gas chromatography, quantitative analysis is based upon comparison of either peak height or peak area of sample peak with that of standard. If the conditions are properly controlled, the peak height and peak area are directly proportional to the sample concentration. Now here in any chromatography, the peak height and peak area are very important. If the conditions are proper, the peak height and peak area is directly proportional to the concentration. Now peak area, it is calculated by using peak height into width of peak at its half height. Now how exactly the peak height and peak area are calculated? Suppose this is the chromatogram of a substance. Now the total height is denoted by small h. This is the peak height. Next is peak height, half peak height. This is the width. WB is the width of peak at its base, and W half is the width of peak at its half height. So these four are very important parameter: peak height, peak half, height of peak at its half, peak width at base, and peak width at its half height. So these all parameters are very important in quantitative analysis. Now these are further few applications of gas chromatography. It can be used in diagnostic purpose. GCMS detects trace levels of compounds present in urine of the patients of genetic metabolic disorders. GC is also used for testing environmental samples to monitor pollution. It is also used in food analysis. Aromatic compounds such as fatty acids, esters, aldehydes, alcohols, terpenes present in food and beverages can be easily analyzed by using GC. GC is used in pharmaceutical industry to check purity of APIs, active pharmaceutical ingredients. GC is used for analysis of inorganic gases, aromatic solvents, detection of impurities and allergens in cosmetics. So this is all about gas chromatography. I hope you understood all these points. If you like my video, please share it and subscribe my channel, and thank you for watching my video. Thank you very much.